Hi, this is Mrs. Basin, and today we're going to talk about factors that affect solubility, which is section 17.5. So when we look at this, things can affect solubility, just like if you think back to when we talked about weak acids and the common ion situation there, having a common ion in solution affected how much of the acid dissociated. The same thing applies here. If you have a common ion in solution, it's going to affect how much of a substance can dissolve. So if one of the ions in a solution is already dissolved in the solution, it's going to decrease the solubility of that particular salt. So if you have, for this particular one, we're looking at a solubility curve for calcium fluoride over here. So if you notice, the solubility is going to decrease as fluoride ions are added to the solution, which is a common ion. So you've got pure water up here, so this is the solubility here, but as they're adding sodium fluoride, which has the common ion, you notice that the solubility of that substance is going down, which makes sense because it's going to shift the equilibrium to the other side. Okay, so let's look at how that affects it. So if we have, it says to calculate the molar solubility of CaF2 at 25 degrees Celsius in a solution that's 0.01 molar in calcium nitrate. So we're going to start these the same way, where we do our calcium fluoride. We show how it dissociates. This is going to be a solid, so we leave that alone. And then this time, we have to look and see what it's dissolved in, and see how that could affect, or which ion that's going to affect. So since this common ion is calcium, we're going to put that molarity in calcium's box here. So it's 0.01 molar. There's nothing that contains the fluoride ion, so that's going to be 0. They are not giving us, and actually the other thing they should have given us here should have been the KSP. So our KSP would have been given, and it should be 3.9 times 10 to the negative 11. Okay, so this would be plus x, and this would be plus 2x, again because of that coefficient there. So this is 2x, and this is x. This is 0.01 plus x. Okay, so then I have my KSP. I know that's going to be calcium times F minus to the second, and then I'm going to substitute in my values. So I'm going to go back up here, so there's my value. So my calcium value is 0.01. We're going to do the same thing that we did before, assume x is small when it's in that equilibrium column, when it's being added or subtracted, so I'm going to leave that. And then this is 2x squared. Okay, now I can use all that to solve for x. And what x gives me here is 3.1 times 10 to the negative 5th molar. And what this is asking for is molar solubility. So when you solve for x, that's giving you the molar solubility. So that's all you have to do for that one. You don't have to do that second step like we did for the other one.